today, so I'm probably the person separating you from lunch, so I'll try to be quick. I was asked to address, when it comes to fracking, what about the safety concerns? And what about the larger economic issues? So those are the things that I'm going to take you through. And the first thing I want to take a look at is fracking perceptions versus reality. And what you commonly see is a graphic that shows the horizontal well, it shows the rig, it shows the trucks, it shows the homes, and it shows the groundwater. And it shows them really close together. So groundwater contamination is absolutely a concern of the public. And following that are earthquakes. And there's a perception that fracking is related to earthquakes. Well, fracking is earthquakes. And we'll talk about that in detail. And then there's the overall concern about the industrial impacts. So those are the concerns of the public. My concerns with fracking are around the surface contamination. It's an industrial process. Spills are possible. And I think the industry does a good job of ensuring that the frac chemicals stay where they're supposed to stay and we're not contaminating these sites. But it's always a concern that I have in any industrial operation, whether it's offshore in the deepwater Gulf of Mexico where my team operates, or any rig operating in the US. And that can absolutely be managed with good management techniques surrounding safety. The other operation, and I think you used the term organized chaos on a frac job. Yeah, it's the safety of the people executing the job. You are pumping a tremendous amount of liquid, a tremendous amount of materials at tremendous pressures. Your pipe had better hold. If your pipe gets away from you, people get hurt. So I'm very concerned about job safety. That's still the only thing that truly keeps me awake at night. I'm asked about what I'm concerned with when that phone rings. And I said, when that phone rings and I pick it up in the middle of the night, my concern is that I've had an incident in my operations and someone got hurt. That dominates my concern. And there's ways you can mitigate that. I'm working to help improve safety across the industry. And one of the things I came across from my foreman brought up earlier is, can we take a look at the airlines? So right now we're working with American Airlines, and we've actually engaged with them. We've had a chance to observe how American Airlines and their staff interact with the FAA. It is impressive, really impressive. So I'm advocating and pushing really hard to bring the FAA role that they work in combination with the airlines, operating cooperatively to improve airline safety. And the record is phenomenal. And I'd love to see that get into the oil and gas industry. And then when it comes to earthquakes, I do have a concern with earthquakes, but it's not associated with fracking. It's associated with the deep wastewater injection above fracture pressure in disposal wells. There's disposal wells all over the country, not just in where fracking goes on, but we dispose of all kinds of materials with deep water injection. And I'm very concerned about it because anytime you inject vast amounts of materials above the fracture pressure of the earth, you're going to split the earth. And you do that continuously with vast quantities of wastewater, you're going to induce earthquakes in areas that have the seismic tendencies to generate earthquakes. And that's exactly what happened in Oklahoma. Those earthquakes have now been mitigated because the state has come in with better regulations, better understandings, and they're limiting deep water injection of waste. It's not fracking, it's waste disposal. That's the issue, and that's where people get confused because a lot of the waste does come from the oil operations. And in the Marcellus, they're recycling it. They're not deep injecting it, and they're doing a great job. And those learnings from the Marcellus, in my mind, need to be transferred to other areas where fracking goes on. But taking a look at the public's concerns about fracking, my goodness, it's going to contaminate my groundwater. As you saw in the picture that's shown there on the left, yeah, fracking is real close to groundwater. No, it isn't. The depiction on the right is a better example. Fracking is thousands of feet to miles away from the groundwater. And I'm going to go over well design on the next slide and show you why it's not a concern. The next concern is that I am blasting the earth and the frac goes everywhere. Well, the truth of the matter is it doesn't. Prior to doing a frac, we actually measure the strength of the earth at spots as we construct the well and also at spots before we do the frac. It's called a pre-frac. You do a pre-frac and you actually generate a fracture for a short period, and that goes into your modeling. And that modeling is done real time on the job. We'll do it immediately, an hour or two before the main frac. We'll execute that work. We'll take that actual pressure required to frac the rock at that exact spot into our rock mechanics models, and we actually design our job on the fly. The modeling and the computing capability is phenomenal, and you can actually design your frac so the frac goes where you want it to go. Because one thing you don't want to do on a frac is have it get away from you, and now I'm fracking out beyond where the oil and gas are. Now I'm exposing myself to other fluids, typically salt water, that's now going to contaminate my well. Good God, that's the last thing I want. It's going to really impact my productivity and the overall cost of the job. The next thing is like the overall industrial impact. You know, we see the picture of the rig and those pads. That's not permanent. A well can actually be drilled in days, and the total time required to drill up a pad is now measured in months. So it is a temporary impact. It's still an impact on the community, but it is temporary. If you ever get the chance to drive north on I-25, or it's 15, I lost track, north of Denver, I'm always amazed at the size of the pads that are there. They put very nice trees around it and everything, and I think millions of people drive by those frac pads, and they don't even know what they are, because that's how well they blend in after the job is done. So the depiction on the right with just the pad and some what are called Christmas trees on the top, that's the norm. The industrial impact is very short-lived. And then earthquake, oh my gosh, my home is at risk. And I'll cover earthquakes in detail on the next slide. So when you look at how a well is constructed, the first thing you do is you drill your surface casing. You drill down a large diameter hole. I'm going to put steel pipe in there, and then I'm going to pump cement. I'm going to bond the cement from the rock to the steel. And I'm actually going to measure the strength of that bond such that I actually measure, before I drill out of that surface casing, I'm going to drill out a few feet, and I'm going to close in my blowout preventer valves, and I'm going to pressure up on the earth, and I'm going to induce a small fracture. I'm actually going to measure the strength of the rock right there, and I'm going to make sure the rest of my well activities never exceed that pressure, whether it's in further drilling or further deepening of the well. So we really understand what it takes to protect the groundwater. And then I'll either run another string of pipe, so there'll be 2 strings of pipe with cement across it, or I'll actually go into my production zone, I'll run my production casing, and that will also be cemented in place. So I've got additional barriers. I might run acoustic logging tools that will actually measure the strength of the cement bond all along my entire wellbore. I can actually measure that with acoustics. And now I've got total confirmation my barrier is in place to fully protect the groundwater. And then, as I mentioned, when I go into the actual fracking job itself, it's done in stages, sometimes massive number of stages. In this simple diagram, there's 6 stages. It's done in stages. It's not done all in one spot. And we'll design the stage of each frac to reflect the change in rock properties as we go along. So at the end of the day, we actually have a very targeted fracture and a very safe operation protecting the groundwater. So earthquakes and fracking, real quick, rock mechanics 101. There's a rock, it's got grains of sand, and it's got fluid in between it, and the fluid could be either water, oil, or gas. And all sedimentary rocks have grains, either silt or clay in the more shale, or grains of sand. And they all have to support what I call the stuff above, the overburden. And there's 2 ways that that overburden is supported. There's the fluid pressure in the actual pores, and then there's the grain-to-grain stress between the rock grains. So that's it. That's all you have to support that load. And as you go ahead and you generate a frac, you have to put enough pressure, hydraulic pressure from your fluid in your pumps, to exceed the fracture pressure of the rock, which is a combination of the pressure in the fluid plus the stress in the grains of sand. And when you do that, you are going to generate small earthquakes. They are too small to be felt on the surface unless you have a seismograph. And they will actually put seismophones around in a field to actually determine exactly where they're fracking. You can also put tracers, chemical tracers that you can read with various tools to actually evaluate where your frac went. And long term, once the well produces enough volume of fluid that exceeds the volume of water and sand that you put in to frac the well, once you've taken more material out than you've put in, you've lowered the overall stress state of the system. And you can make an argument that on a regional basis, you've actually decreased the tendency for earthquakes and not increased it long term. So that's where the basic safety issues, and maybe I've convinced you it's safe, I hope I have, but is it economic? In terms of oil resources, the U.S. is a lot like Venezuela. As I went over this morning, we have resources, but do we really have reserves? It's only resources are not reserves. Reserves are what make the world go round. It's what is resource is what's physically there, but a reserve is what you can actually produce economically. You actually have a viable business. And reserves are only resources is the first step to dominance. At the end, it's reserves that really matter. And do we only have big reserves when we have high oil prices? Or can U.S. shale compete at lower prices, and how low is low? So I showed the slide earlier that we transition to there if it turns out that the shale play is real. Our reserves production ratio gets to a level where we can compete in the world. So great, is that real? Well, what oil price you want to use? How about the average Joe oil price? So that's normalized to $2015. What is the price at which oil was above half the time and below half the time? And that price turns out to be $55, 50 to 55. Today we're at 57. So today we are very, very close to the average Joe oil price. So if you're going to evaluate fracking, you have to be viable, I think, in about the $40 to $50 a barrel range. And according to Bloomberg Intelligence, it's interesting to note, there's your line at 50. And notice that in the primary fracking fields of the U.S., be it the Bakken, the Eagle Ford in South Texas, or in the Permian, all of those things, their break-even price is now below the current oil prices, which means from an economic standpoint, the vast majority of those fracks are indeed viable. So the trends say, yes, we can. What's interesting when you look at oil wells, this is a graph, and as you can see, it starts off in the year 2008. They were getting about 50 to 25 barrels a day is what a well would initially produce when they started fracking. But getting better frack designs, better proppants, as we went into the last presentation, more rounded fracks that don't damage and permeability as the grains get crushed. You can see the production has increased, such that by 2015, in the Permian Basin, you were up to an average oil production of 225 barrels per day for the first month. But look how fast it drops off. And that character still stays there. So that's still there. What about that long-term tail? And what's really going on? I really believe that in our shales, what you have is a micro-fracture network in our shales. And what you're doing is you're drilling a well down, you go horizontal, you link up all those fractures, and those fractures are full of oil, and that's what you're actually producing from. So once you've linked up those fractures with your frac from your well, and that produces, and you get that flush production, that's why you see that great decline, because the permeability in the rock itself is so low it struggles to produce. But what's really interesting is, this is that same chart I showed you, and you'll notice in those zones you're looking at 300 or 400. Look what's happened in the last year and a half. In the areas of the Bakken, in the Eagle Ford, they're actually at 1,400 barrels a day. From 250 to 1,400 barrels a day per well is what the average production gain is due to changes in fracking techniques. Now the question is, are you still going to see the big drop-off? Are we really discovering new oil, or are we simply accelerating forward oil we would have produced anyway? Acceleration is huge in project economics, but are we really accessing new oil? And the answer is, I don't know. And I'm real curious to find out if it has legs. If it is true and we are accessing new oil, then we will clearly dominate shale on a global basis. So you can see as the increasing changing fracking techniques, you see the drop in production when the rig count dropped, but then the economics improved, bigger fracks, higher oil production, you're getting to pay out on your well, and you're making money on that long tail, and you can see production has gone back up, and today API announced U.S. oil production was 9.6 million barrels a day last week, the highest we've had in 40 years. So impressive stuff. So that's our numbers. How well we understand it, that's a big question mark, and that's what research is dedicated towards. I know I got 1 minute, I'm wrapping up quick. All the oil companies have foregone their research R&D programs. R&D now occurs in America's universities and the petroleum engineering departments, and there's only 19 of them. But the research that is going on there is highly focused on the tight oil play. So there's some amazing things that are happening out there. So in summary, fracking is safe, has the potential to unlock vast resources of domestic oil and gas, but to export globally on a significant scale, we need to have the reserves. Economic trends indicate we're economic even in the 40 to 50 barrel range, and long-term, those uncertainties still remain. New technologies and understandings are needed to further add value and security to America's oil and gas future.